So when we look at matrices and we want to do operations on them, right, like adding, subtracting, multiplication with matrices, what's really, really important that you have to know how big the matrices are. Okay? So it's critical to know the dimensions of the matrix. So that's something we talked about on Tuesday, right? How to look at the dimensions of a matrix. Just as a refresher, okay? The dimensions of a matrix are always labeled by rows first and columns second. Okay? So again, that's just been kind of the agreed upon way to do that. If we all do it that same way, it just keeps everything clear. Okay? And for me, it's easier for me to think about what a column is because I know columns in buildings go up and down. And so when I think about columns going up and down, right? So that's those. So then rows must be going the other way. Right? So there's 2 rows and 4 columns. And so we say 2 by 4. Right? We say 2 by 4. We just write 2 in the little x, 4, right? The x does not mean multiply, it just stands for the word by, 2 by 4. Okay? So that's a 2 by 4 matrix. 2 rows, 4 columns. So Connor, what about the next one? How big would it be? Yeah, you. 3 by 2, is that what you said? Okay. 1, 2, 3, 3 rows. By 2 columns, okay, 3 by 2. Dawson, what about C? 2 by 1? Two rows, 1 column, okay. 2 by 1. That's why you guys make your own 4 by 3 matrix. There doesn't really need anything to be special about what numbers you put in here. On your homework, you guys are going to be asked to just make up some of your own matrices too. There, I've given you guys a little bit of criteria about what numbers to put in there. Here, just use kind of any number you want. I wouldn't, just avoid decimals. There's nothing wrong with them. It just makes things messier. But throw some negatives in there, throw some positives in there. Don't put any giant numbers in there. But just make a 4 by 3 matrix. Right, we're going to use it later, so for something else. But should have 4 rows, 3 columns. Okay, 4 by 3. So just use whatever numbers you want there. Put brackets around it. That's how we hold a matrix together. Okay? Let's make something up. Okay. So in order to add or subtract matrices, they must be the same size. Okay. So we have to know what the size is if we're going to know that they're the same size. We have to be able to identify the dimensions of a matrix in order to know if we can add it to another matrix. So if we want to add them, they have to be the same size. So just, really quickly you look at the matrix and you say, okay, it's got 2 rows, it's got 2 columns, so it must be a 2 by 2. This one's got 2 rows, it's got 2 columns, so it must be a 2 by 2. And since they're both 2 by 2s, that means we can do this problem. Okay? It's possible. If they're not the same size, then it's not possible to add them. Okay? So it's possible. And then from there, knowing that it's possible, it's actually really, really easy to add matrices. Okay? You guys in geometry talked about corresponding angles. Here I'd say corresponding elements or corresponding entries. You can call the numbers in the matrix an element or an entry. Okay? So the 6 and the 0 are corresponding elements. Those are the ones they're going to add. And then the 3x would add to the 4x, and then the The -2 would add to the -5, and the 8 would add to the -3. So you're just adding corresponding elements. That's all it is. Okay? They have to have something to match up to. That's why they have to be the same size. So 6 plus 0 is 6. 3x plus 4x, 7x. -2 plus -5 is -7. And 8 plus -3 is 5. I just threw some variables in here so you guys can see that they don't change anything. So just a matrix like this is just an array of numbers. There's some sort of data that's being kept or something like that. Okay, these would not be systems of equations. This is not an augmented matrix. Okay, it's not a system of equations. It's just some sort of data, some sort of array of numbers that's being kept. Okay. So subtraction is pretty similar. You just got to make sure they're the same size. So see 1, 2, 3, 4 column rows, 1, 2 columns. So it's a 4 by 2. And this one also has 1, 2, 3, 4 rows, 1, 2 columns. So it's also 4 by 2s, right? So you guys don't, when you guys are doing this for yourself, you don't have to write that down. I'm just doing that for you guys. Like, okay, it's a 4 by 2, it's a 4 by 2. We're good to go. Okay. You guys do need to be checking, but you don't need to write it down. Are they actually the same size? Right? So make sure the problem is doable first, and then move on from there. Now, with subtraction, of course, we need to be a little bit more careful. We're more prone to make errors with subtraction than we are with addition. So I really just suggest that you're reading very thoroughly to yourself as you're doing this. I'm going to stop there. 1 minus -4. Minus a negative means add. So 1 plus 4, that's 5. Okay. Be careful with your addition, right? 1 minus -4 is 5. 4 minus 4, of course, is 0. 7 minus 5 is 2. 11 minus 3 is 8. So you just need to slow down with subtraction. Just make sure you're reading to yourself, okay? What would I have next? 1. 10 minus 9 is 1. Okay. What's next? -7, yep. 0 minus 7 is -7. What's next? Oh, 2, yeah. -6. -2 minus -4. What happens there, Jeff? Okay, turn to add, so 2. And the last one, 3y, okay. 5y minus 2y is 3y. There's our difference there. Just be careful with subtraction. So it's just a little bit messier. C. So we've got 1, 2, 1, 2. So this is a 2 by 2. 1, 2, 3 by 1. So 3, 1. So those are not the same. So this problem is not possible. Can't add them because they're not the same size. Right? They just don't have anything to match up with. Like the -2 can match up with the 6, and the 12 can match up with the -2, but then the 5's got nowhere to go, and the 0's got nowhere to go, and the 7 doesn't have anything to add to. So they don't match up. Okay? And then the last one here, right, just having multiple things to do. It's just addition and subtraction, right? It's all happening on the same level of PEMDAS, right? It's all addition and subtraction. So you always go left to right with a problem like that. I wouldn't try to do all this at once. That's just going to get to be too much. So just do the first two things, right? It says add these two things. Let's just add those two. Okay? Then we'll worry about the subtraction next. Okay? So Natalie, what we get when we add those two first ones? You go. Okay, so 11, 11, negative 12. Thank you. And then want to do the subtraction. Again, just be careful that you're subtracting. Right? 11 minus 15, negative 4. 11 minus 2, right? 9. Negative 12 minus negative 12. There's nothing wrong with writing it down, guys. Negative 12 minus negative 12. That's negative 12 plus 12, which is 0. So don't rush through it and make some silly mistake. It's just addition and subtraction at its heart, so there shouldn't be anything difficult about it, but certainly there's a lot of numbers. It's just a lot of opportunities to make silly mistakes. So. Anything about adding, subtracting? Seem like you guys need me to clear up for you? You good, Brooklyn? Good, Stella? Hi? Okay, so the next thing here is scalar multiplication. So this is not a matrix times a matrix. We're going to do that tomorrow. Okay, this is scalar multiplication. So what we're going to see there's just a number here on the outside. Okay, so essentially what we're doing here is just taking each of those numbers times 4, or taking each of those numbers times half. Okay, so this is essentially just distribution. It's just a big distribution problem. I've collected all my data, and then I want to take all that data and multiply it by 4. Okay. It's just a big distribution problem. Again, so it really just tells you this, all you need to do is slow down, make sure you don't miss something. Of course, 4 times 1 is 4, 4 times 4 is 16, 4 times 7 is 28, 4 times 11 is not 11, 4 times 11 is 44. Jet, what would the next row be? Okay. Jacob, what would the bottom row be? Negative 8, okay, and? Okay. All right. So of course we can distribute a fraction just as well. So just a half times each of those elements times each of those entries. Lucas, what would the first row be? -1 and 2.5. Yeah, it's good. You know, if you need to use a decimal. Right? Maya, what about the last row? So then just taking that and just expanding it a little bit. Okay? So what if I had addition and multiplication at the same time? Okay. You know, for me, what I would do is I would take care of the multiplications first. All right, so I'm going to go ahead and multiply by 2. I'm going to go ahead and multiply by 3. And here you guys need to make a decision about that 4. Okay? Is that a 4 and then you're going to subtract later? Or is it a -4 that you're going to distribute and then you're going to add later? You have to make a decision. You can't do both. I can't call it a -4 and then subtract later. Okay? It's either a -4 that I'm distributing and then I'm adding later, or it's a 4 that I'm distributing and I'm subtracting later. You need to make a decision. Okay? You can't do both. It's one or the other. Okay? I'm going to do the +4 and then subtract. So that first matrix gives me 18, 28, -10. Tatum, what would the second one be here? Okay, 6, -9, -21. Minus, right? I'm going to call that a 4. So 4 times 15 is 60. 4 times 2 is 8. 4 times -12 is -48. You know, just like when we did this one earlier, I would take those first 2 and combine them, then worry about the third one. Don't try to do it all at once. Okay? So, if you try to do too much at once, you're just going to get messed up. So I'm going to add those 2 first. 18 plus 6 is 24. 28 plus -9, so 28 minus 9 is 19. -10 plus -21 would be -31. So just make sure you're talking yourself through this, right? It's row by row. All right, do that subtraction. And hear me say it: 24 minus 60, 19 minus 8, -31 minus -40. I'm always reading that. I'm not just looking at the numbers. I'm making sure I'm reading that. And if you need to use a calculator, use a calculator. Don't. I don't care. Just get it done right. So 60 minus 24 would be 36. So 24 minus 60 would be -36. Henry, what about the next row? 11? Okay. Ella, what about the last one? Continue. -31 minus -48. So -31 plus 48. 17. So I want you guys to take your 4x3 that you guys had earlier, bring it down. Okay. Multiply by -2. Okay. It's your new matrix. Use the one that you did earlier. Okay. Just bring it down and then multiply by -2. Try to impress upon you guys with this on Tuesday was that it's kind of like synthetic division in the way that we just strip all the variables away. We're just dealing with the numbers. And like in that first time you guys did synthetic division, how it just seemed super weird, but that started making sense. Okay? And it's going to be that same way. It's going to be really weird and awkward at first, but then it'll start making sense. And the other thing too is so in that way that we're stripping all the variables away, Okay. But the other thing is that it's, essentially most of what we're doing is like the elimination method that we did on Monday. You guys generally have a pretty good feel for the elimination method. So how do we take those ideas and kind of combine them? Okay. But we have a system of equations. The first thing I want to do is write it as a matrix. In this case, it's an augmented matrix because of the equal sign. So the 1 goes on the other side of that bar. -2, -7, 17. Writing it as an augmented matrix since it does represent an equation. And we're trying to get it into reduced row echelon form, which looks like this. 1, 0, 0, 1, and then the numbers on the other side of the bar, they're whatever they are. We get to make all the decisions about what happens on the left side of that bar. The numbers on the right side of the bar are just going to do whatever they do. We don't control them. We control what happens here. Okay? We get to decide what to do over here. We don't worry about what happens over here. Just let it happen. And in general, the easiest path through this problem is to start at that top left corner, figure out how to make that a 1, move down that left column, move across the bottom row, and then move up to that thing. In general, that's the easiest way to get through these problems. Not always. Okay. So what I saw a lot of on, from those of you guys that did turn your homework in, was that, in the case where this wasn't easy to become 1, you guys just kind of went and said, well, I'm just going to divide that by 5 or divide it by whatever. And then you end up with fractions. And you have to do a bunch of fraction work after that. Okay? What I want to talk today is how do I avoid using fractions? And sometimes it's not avoidable. You can't, there's no way out of it. Okay? But in all the problems that you guys had on that worksheet, that didn't have to do fractions on any of it. Okay? Just changing the way you think about it instead of just defaulting to division. It's not always the way to go. Okay? So if I want a 1 here, but I've got a 5, just stop looking at the problem and say, how do I turn a 5 into a 1? What do? How do we turn a 5 into a 1? Divide by 5. Okay? But if we divide by 5, what happens? Right? That turns into a 1. I get some sort of decimal / fraction. I get some sort of decimal / fraction. Don't really want to do that. So I need another way. How else do I turn a 5 into a 1? Subtract 4. I already said that. Yeah. Why'd you do that though? Because you wanted what? You wanted the -2 to be did 2 times this, right? So you said? Because you wanted this to be what? -4, right? So 5 plus -4 is also 1. Okay? But multiplying this row by 2 is not going to create fractions. It should make it a cleaner problem to work through. Okay? So what's a different way to approach it? We have 2 options. Let's pick the cleaner one. Right? Again, mathematically, they're both going to work. It's just, do you want to work with fractions or not? Right? Can we avoid it? So just think about that. What are my options? How do I get a 5 to be a 1? I divide by 5, but that makes this messy. I could add -4 to it. Okay, that'll be clean. Let's do it that way. Okay. So again, I want you guys to make sure you're writing what you're doing next to, or writing it down. It doesn't matter necessarily where you, sorry, I wrote that wrong. It doesn't matter necessarily where you write it. I always write it next to what I'm trying to do. I'm trying to change row 1 right now. So I always write it next to row 1. Okay. What I'd really suggest next, and this is something that, the first time I taught this, I didn't kind of have this like little tip. It did lead to issues, is that as soon as you decide what you want to do, you go and write down that row that you're not trying to change first. Right? We're not trying to change row 2 yet. So I want to write that down first so I don't accidentally mess it up. Okay? So get it transferred over. Okay? And I talked to you guys on Tuesday about you just kind of have an open mind here. Like we're saying we want to multiply this by 2, but we're not actually doing it, right? Not actually changing the row. We're just using this really temporarily, but then we're just going to let it go. Okay? So that's just something that's a little bit different about this thinking, that we can temporarily take row 2 times 2 and then add to row 1, but we're not actually changing it. Okay? So it's just a little bit different thinking, but it's okay to do that. Okay? We see that it works. So I'm taking everything, and so now that I've filled in that row that I don't want to change, now I go back and say, okay, I do want to multiply that row by 2, so I need a place to do that work. And so for me, I always like to put it next to the thing I'm going to end up adding it to. So I'm going to take these numbers, multiply by 2, but put them up here. That way when I go and add them, they're next to each other. This helps my eyes. Rather than putting the numbers down here, then I have to like try to add across something. So I'll take this row times 2, I'm going to put it up here, that way, and then I'm going to add down. So that'd be -4, -14, and 34. I want to add. So there's that 1 we wanted. And then we get -11, and then we get 35. As soon as I'm done, I go back to my key, my map, whatever you want to call this thing. Say, okay, there's that 1 I wanted. What's the next thing I do? Okay, go down that column. Next thing I want is that bottom left to be a 0. I just think, right? Detach myself from the problem. How do I take a -2 and turn it into 0? What are my options? Add 2. What else can we? So -2 plus 2 is 0. That's another way to take -2 and get 0. What else can you do to -2 to get 0? Not detach from the problem. What are options? We have a -2. We want to turn it into a 0. What do we do? Add 2. What else? How do you turn any number into 0? Careful, Al. Division by itself doesn't give 0. Multiply by 0, right? 2 basic ways to take a number and get 0. You add its opposite, or you multiply it by 0. Which works here, right? Yeah, we can't multiply, LSM, we can't multiply a whole row by 0. So if I want to multiply that by 0, I have to multiply everything by 0. And that just kills the whole equation. Now I have one equation with 2 variables. That's impossible to solve. Okay, so you're not allowed to multiply a row by 0. Oh, I don't know that anybody brought this exact statement up in class on Tuesday. Somebody brought it up in the first hour. But I did see some people doing this. So you do need to make sure if you turned your homework in, there were 2, 3 people I saw do this. So make sure you go back and look at your feedback. You are not allowed to just subtract 2, okay? or add 2. I can't just add a 2 to this. I did see some people saying like row 2 plus 2. You can't do that because that's not a -2. Okay? It's not a -2. It's -2 x's. -2x plus 2 is not 0. Okay? We stripped the x's and the y's away, but they're still there. That's still what this represents. I can't just add 2 to this. I have to add 2 x's to it. -2x plus 2x is 0. Okay? Well, where do I get 2 x's? Well, I have 1 x here. Well, I could double that, and I'd have 2 x's. Okay? So you're not allowed to just add or subtract a number. I can add or subtract a row because those rows are also made up of x's and y's. Okay? These over here are numbers. We're not trying to control them. All right? We're trying to control the variables. Okay? Yeah, exactly. Maya was asking like that's why I did this, right? Because I have 5 x's, so I need -4 x's. I can't just take 4 away from 5. Yeah, exactly. Okay? That is kind of the weird thing, right? We strip all the variables away, we lose the context, right? So we start thinking maybe we can do stuff that we end up mathematically we can't. Okay? But it saves us a lot of writing because we don't have to write all the variables. We just got to keep in our head that that's not a -2, it's a -2x. So I need 2 x's, so I'm going to take 2 times row 1. I'm going to add it to row 2 because that'll give me 0 there. Okay? But I'm not trying to change row 1, so I'm going to bring row 1 over immediately so I don't accidentally mess it up. And the other thing that does is it creates this space here. Like this is the only space for me to put my new numbers. I don't accidentally put them in the wrong row. So I've decided what I want to do. I immediately go write the other row down, and then I go back and I do the math I said I was going to do. I said I want to take 2 times row 1 and add it to row 2. Again, I always like to put that right next to the row I'm going to add it to. Make sure I'm going to multiply those numbers by 2. So 2, negative 22, and then 70. And then I add. Zero. What's that? Negative 29. And 87, yep. Again, no fractions, right? Got some kind of bigger numbers there, but no fractions. So as soon as I'm done with my step, I go back and I look at my key, look at my map, see where am I? I've got 1, 0. That's the next thing I need. I want a 1. Again, detach yourself from the problem. You have negative 29. How do you turn it into a 1? There are 2 ways of doing that. Divide by negative 29. Right, negative 29 divided by negative 29 is 1. That's another way of getting negative 29 and turning it into 1. What else can I do to negative 29 to make it into a 1? Stop looking at the problem and just think, how can I take a negative 29 and turn it into a 1? Already got that one. Yep. We could add 30. Right, there's another way. Right? Can I get a 30? Right? Well, that's 29 y's. I would need 30 y's. I can't turn 11 into a 30 very easily at all. Okay? And if I tried to do that, I would have to add this 1 down here to the 0. That would mess up the work I did. So I don't want to do that. But is dividing by 29 going to create problems? 0 divided by 29? 0, right? What's 87 divided by 29? 3. Okay, so that 29 comes out cleanly. Of course, that's a negative, so it's going to make this a negative. So now we see that this division, which we tried to avoid here earlier, because this is a 0, doesn't give us problems. Okay? So by having that 0 there now, we're good to go with that division. Okay? But that 3 was kind of saying, don't divide me. Okay? So now the division works. So row 2 divided by negative 29. Again, I'm not trying to change row 1, so I bring it over immediately so I don't accidentally screw it up. Then I just go back and I do that division. It should be pretty simple. 0, 1, and negative 3. So go back and see where we are. So we have one more step. Okay. And pretty much, if you're trying to get a 0, especially at this stage of the problem, there's really only one way to do that. We can't multiply by 0, right? That's just not okay. You have to be able to add the opposite. So we need 11 y's to add to that. So we're going to turn that 1 into an 11 and then add it to that. We're going to multiply that row by 11 and we'll add it to that. I want to add the opposite to this. I really would suggest you guys don't ever try to do subtraction. Again, just like we saw with the matrix subtraction stuff, it's really easy to mess up. I really would add opposites if I was you guys. So just word to the wise, right? Don't try to subtract. It just doesn't work out very well most of the time. There's nothing wrong with it mathematically. It's just people just suck at subtraction. It's really what it is. We're so much better at thinking about adding opposites. So 0 times 11, 1 times 11, and negative 3 times 11. And add. Because that was negative 29. So we get 1, 0, 2. So there we've met that goal, right? With the 1, 0, 0, 1. And the whole point of this is that now we know what x and y are. And that's 1x with 0 y's with it is 2. So that means 1x equals 2. The second row is 0 x's, but 1 y is equal to -3. I do want you guys to write your answers as ordered pairs. So that'd be 2, -3. You should be able to quickly check it. Nothing. So 5 times 2 is 10. 3 times -3 would be -9. So 10 plus -9 is supposed to be 1. 1 equals 1. And -2 times 2 is -4. -7 times -3 is +21. It's supposed to be 17. And 17 equals 17. So see that our answer works. We don't necessarily need to do the whole next one. This problem here with B is very much like whatever the top right problem is on the worksheet from Tuesday. So I wanted to show you guys how to start it. At least once you have it started, it's pretty easy to keep going from there. But this one had, like I said, this was the one that I had to stop and look at and go like, what do I do here? Because it doesn't act like a normal problem. So there was somebody, I think it was somebody in this class that did the problem in a really interesting way. I thought it was pretty cool. I made a comment on your paper. I can't remember who it was, but it's an interesting method they went through. So. Maybe it was somebody in 6th hour. I can't remember. So just flipping into a matrix real quick, but then I'm just going to go back and look at my key or my map. Right? I want that top left to be a 1. That's usually where we start. And so we look at that -2. We say, okay, well, I can just divide by -2. But then that's going to make this 9 into something I don't really want to deal with. Okay? So I don't want to divide by -2. Right, well, so I take -2 and turn it to 1. I could also add 3 to it. But I don't have an easy way of taking a -2 and turning it into a 3. So it doesn't really seem to be an easy way to make this -2 into a 1 right now. And I say, well, I'm going to go look at something else then. Right? What could I do? I'm just going to start in a different place. So a couple of things, choices. There is a really easy way to make that into a 0. Okay? Because if I had -2 and +2, I could make that a 0 really easily. There also is an easy way to make that into a 0. 9 plus -9 would be 0. So I could start in either of these corners now and see what happens after that. So you don't have to start here. Right? It's not a hard, fast rule. It's just that generally that's the easiest place to start. There's just not an easy way to make that a 1 right now. So I'm just going to go look at something else. Okay? So I'm just going to make that into a 0. I'm just making a choice. Make that into a 0, make that into a 0. It's going to start somewhere else. See what happens. So I want this number to be a -9, so it'll cancel that. So I'm going to multiply this by 3 and then add it to that. So I'm taking row 2 times 3 and adding it to row 1 to try to make this a 0. Okay? But I can avoid getting fractions by doing that. So I'm not changing row 2. I'm going to bring it down since I kind of wrote into this space. Not changing row 2, so it's -2, -3, and 4. That would be -6, -9, and 12. So when I go to do those additions, get -8, 0, and 40. So now I have a 0 here, and I go back and I look at this and say, hey, can I get that to be a 1 now? I want to divide it by -8, and dividing 0 by -8 isn't a problem. And dividing 40 by -8 also isn't a problem. So now all of a sudden getting that 1 becomes easier. Okay? So just a different way of starting it, which then ends up making it a lot simpler. So again, that problem was particularly tricky. That I wouldn't normally have given that to you guys as a first day problem, but so I just wanted to kind of help you out with that. So you guys have 2 of those on the back of the worksheet. Just want you guys to try those, see if they're making any more sense now. Obviously, there's more to do there, but we're out of time. Okay?